The cabin stood alone on the exposed ridge, smoke rising straight from its chimney, while 300 feet below, the town of Silver Point lay buried under 8 feet of snow, with half its structures collapsed or torn open by wind. Eleanor Hartwell sat by her fire, warm and dry, listening to the blizzard's fury fade into morning silence, knowing that the men who had mocked her 6 months earlier were now digging their families out of the rubble. Before we go further, drop a comment telling us where you're watching from, and if stories of survival and determination inspire you, hit that subscribe button because tomorrow's episode will leave you speechless. The year was 1881. The Colorado mining territory was still rough country, where fortunes were made and lost in the span of a season, and where the mountains killed without mercy or warning. Silver Point sat in a narrow valley at 7,800 feet elevation, a collection of roughly 80 buildings clustered around a main street that turned to mud every spring and froze solid every winter. The town existed because of the Redemption Mine, which had been pulling silver ore out of the mountain for 7 years with enough consistency to support a population of nearly 400 souls. Eleanor Hartwell arrived in Silver Point on June 3, 1881, driving a wagon pulled by 2 mules she had purchased in Denver. She was 34 years old, dressed in practical traveling clothes that showed wear but were well maintained, and she carried herself with a quiet dignity that made people notice her despite her obvious exhaustion from the journey. Her husband, Thomas Hartwell, had died 4 months earlier in a tunnel collapse at a mine in Leadville. Eleanor had sold everything they owned except Thomas's tools, his technical journals, and the small inheritance he had left her, and she had come to Silver Point with a specific purpose. She went directly to the land office, a small building attached to the general store, and filed a claim on 20 acres of land on the ridge above town. The land agent, a man named Porter, who had held the position for 3 years, looked at her claim location and assumed she had made an error. The ridge she had marked was exposed, windswept, and considered worthless. No one built up there. The wind was constant, the soil was thin, and hauling water up the slope was impractical. Porter explained all of this carefully, assuming she was simply ignorant of local conditions. Eleanor listened politely and then repeated her claim. She wanted exactly that parcel, 20 acres on the ridge, and she wanted to file immediately. Porter shrugged and processed the paperwork. It was her money to waste. The filing fee was $12. Eleanor paid in cash and walked out with her deed. By evening, word had spread through Silver Point that the widow Hartwell planned to build a cabin on the ridge. The news was received with a mixture of amusement and concern. Several men, motivated by various combinations of genuine helpfulness and opportunistic interest in a single woman with money, visited Eleanor at the boarding house where she had taken a room. They offered to help her find a more suitable location. They offered to build her cabin in town where she would be safe and close to supplies. Some offered to build her cabin themselves, with various implications about what such assistance might require in return. Eleanor declined every offer with the same calm firmness she had shown at the land office. She thanked them for their concern, acknowledged that the ridge was unusual, and explained that she had her reasons for choosing that location. She did not elaborate on those reasons. When pressed, she simply repeated that her decision was final. By the end of her first week in Silver Point, Eleanor Hartwell had earned a reputation as stubborn, possibly foolish, and certainly strange. The general consensus among the town's men was that she would either abandon her ridiculous plan within a month or she would die on that ridge come winter. Either way, they had done their duty by warning her. On June 10th, Eleanor made her first major supply purchase at Brennan's Trading Post, the largest supplier of building materials in Silver Point. She arrived early, before the morning rush of miners and laborers, and presented a written list to Michael Brennan, the owner. Brennan was a practical businessman who had seen every kind of fool come through his doors, but Eleanor's list made him pause. She wanted 45 logs, each one between 11 and 13 inches in diameter, stripped of bark and cut to 16-foot lengths. She wanted them delivered to the ridge within 2 weeks, which meant Brennan would need to hire haulers specifically for the job, since no one went up there regularly. The list continued. 20 pounds of square-cut nails, not the cheaper round wire nails most people used. 6 iron brackets, heavy. Grade, each one capable of supporting 200 pounds. 4 iron hinges, the largest size Brennan stocked. A roll of canvas 12 feet wide and 30 feet long. 2 barrels of clay, refined quality, not the rough stuff used for basic chinking. A 50-pound bundle of horsehair. 3 gallons of pine resin. A draw knife, 2 different planes for shaping wood, a set of auger bits in graduated sizes, and a specialized tool called a slick, which was used for fine timber work. Brennan read the list twice, then looked at Eleanor with undisguised skepticism. The total cost would be $168, a substantial sum. More importantly, the materials made no sense for a simple cabin. The logs she specified would take time to source, since most timber was cut to standard dimensions and left with bark on. The iron hardware was excessive for basic construction. The clay, horsehair, and resin suggested some kind of specialized chinking mixture that no one in Silver Point used. The tools indicated she planned to do fine carpentry work that seemed absurd for a frontier cabin. Brennan asked Eleanor directly if she knew what she was ordering. Eleanor assured him she did. Brennan asked if she had someone helping her build, because the materials suggested a level of construction that would require skilled labor. Eleanor explained she would be building alone. Brennan set the list down and told her honestly that he thought she was wasting her money. A widow with limited resources should not be spending nearly $200 on materials for a cabin on an exposed ridge that would likely blow apart in the first serious storm. He could sell her materials for a basic cabin for $40. It would be adequate shelter and leave her with money for other necessities. Eleanor appreciated his concern but declined his alternative. She wanted exactly what was on her list. She could pay half now and half on delivery. Brennan accepted her deposit and agreed to have everything delivered within 2 weeks, though he made it clear he thought the whole enterprise was foolish. As Eleanor left, Brennan mentioned her order to the first customers who came in after her departure. By noon, half the town knew the widow Hartwell was spending a fortune on building materials that made no sense. The consensus shifted from thinking she was merely stubborn to suspecting she was actually mad with grief. The ridicule became more open. At the saloon that evening, men who had never spoken to Eleanor discussed her plans with confident dismissiveness. She didn't understand mountain weather. She didn't understand construction. She was a city woman trying to play at frontier life. Some predicted she would give up before the foundation was laid. Others predicted she would complete a cabin so poorly built that it would collapse under the first snow. A few suggested darkly that she might not survive her first winter, and while that would be unfortunate, it would at least serve as a warning to other women who thought they could manage alone in the mountains. Eleanor heard the talk, though no one said it directly to her face. She had expected mockery and had prepared herself for it during the long journey from Leadville. What the men of Silver Point could not know, and what she had no intention of explaining, was that she was not attempting this alone in any meaningful sense. Thomas Hartwell had been with her every step of the planning, even though he had been dead for 4 months. His knowledge, his careful observations, and his obsessive documentation were the foundation upon which she would build. Thomas had been a mining engineer trained at a technical college in Pennsylvania before coming west in 1873. He understood structures in ways that most frontier builders did not. He understood load distribution, compression forces, material properties, and the physics of failure. He had spent 12 years working in mines, shoring up tunnels, building supports that held tons of rock overhead, and analyzing collapses to understand what went wrong. He had kept detailed journals of everything he learned, filling 7 leather-bound notebooks with drawings, calculations, observations, and principles that he had tested and proven underground. Eleanor had read every page of those journals 3 times during the winter after Thomas died. She had studied his drawings of timber joints, his notes on wood selection, his calculations for weight-bearing capacity. Thomas had been planning to leave mining and build a homestead, and he had spent 2 years researching construction techniques that would work in mountain conditions. He had sketched cabin designs, working through problems on paper, testing his ideas against his engineering knowledge. He had never built his cabin, but Eleanor would build it for him, using everything he had taught her. They had met in Pittsburgh in 1871, when Eleanor was 24 and working as a seamstress in a shop that made custom garments. Thomas had come in to order a coat, and had returned 3 times with minor alterations that Eleanor suspected he invented just to have an excuse to talk to her. They married 6 months later. Eleanor had not been educated in any formal sense beyond basic schooling, but she was naturally curious, and Thomas loved to teach. During their 12 years together, he had explained his work to her in detail, showing her his journals, walking her through his reasoning, treating her as a genuine intellectual partner rather than simply a wife to be protected from complicated matters. When Thomas died, crushed under a tunnel collapse that killed 6 other men, Eleanor grieved deeply, but grief did not diminish her clarity of thought. She had no children. She had no family in the East who would support her. She had limited money and limited options. She could return to seamstress work, barely surviving in a city, or she could use what Thomas had taught her to build something permanent. The choice was obvious. She would build the cabin Thomas had designed, modified for actual mountain conditions, and she would prove that his knowledge was sound. That would be his legacy and her survival. The men of Silver Point could mock all they wanted. Thomas's engineering would speak for itself. Brennan delivered the materials on June 24th, 2 days later than promised. The delay was caused by difficulty sourcing the specific logs Eleanor had ordered. Most timber operations cut logs to standard dimensions and moved them quickly. Finding 45 logs within the narrow diameter range Eleanor specified, all 16 feet long and properly stripped of bark, required contacting multiple timber camps. Brennan had to pay premium prices for special cutting, and he passed those costs to Eleanor. The final bill was $183. Eleanor paid without complaint. The hauling crew that brought the materials up the ridge thought the job was absurd. The trail was rough, barely wide enough for a loaded wagon, and the grade was steep enough that they needed to double-team the mules for the final push. They made 6 trips over 2 days, stacking logs, barrels, canvas, and iron hardware on the flat area where Eleanor had marked her building site. The crew foreman, a man named Carlson, who had hauled materials for dozens of construction projects, looked at the pile of supplies and the exposed ridge location, and told Eleanor she was making a serious mistake. The ridge was no place for a cabin. Winter winds would tear it apart. She should reconsider while there was still time. Eleanor thanked him for the delivery and paid the hauling fee. Carlson shrugged and left, reporting back in town that the widow was definitely proceeding with her insane plan. The betting at the saloon shifted from whether she would give up to how long her cabin would last once built. Most men gave it less than 1 winter. Few optimists suggested it might survive 2 seasons if she got lucky. No one predicted it would last longer than that. Eleanor spent 3 days organizing her materials and setting up a work camp. She erected a canvas shelter for herself and her tools, dug a fire pit with a rock surround for cooking, and established a water collection system using the canvas and empty barrels to capture rain. The ridge received adequate rainfall during summer, and she had no intention of hauling water up from town if she could avoid it. She unpacked Thomas's tools, laying them out in organized rows, and she opened his 7th journal, which contained his final and most detailed cabin designs. On June 28th, Eleanor began work. She started before dawn and continued until darkness made precision work impossible. She worked alone, refusing several offers of help from men who climbed the ridge out of curiosity or condescension. One man, a carpenter named Dutch Henry, who had built half the structures in Silver Point, spent an hour watching her work on the foundation. He told her she was digging too deep, wasting effort on unnecessary precision. Eleanor listened politely and continued digging exactly as she had planned. Dutch Henry left, telling people in town that the widow was doing everything the hard way and would exhaust herself before completing even basic groundwork. He gave her 2 weeks before she quit from simple fatigue. The foundation work took Eleanor 3 full weeks, far longer than any experienced builder would spend on such preliminary work. Standard frontier construction typically involved minimal foundation, perhaps some flat stones under corner posts to keep logs off the ground, or in some cases no foundation at all beyond leveling the dirt. Eleanor's approach was radically different. She excavated a trench 18 inches deep around the entire perimeter of her planned cabin, creating a rectangular outline 20 feet by 16 feet. The dimensions were specific, taken directly from Thomas's calculations about optimal interior space for heating efficiency and structural integrity. The excavation itself was brutal work. The ridge soil was thin, only 6 to 8 inches deep before hitting rock and compacted gravel. Eleanor used a pickaxe to break through, then shoveled out the loosened material. Her hands blistered, then calloused. Her shoulders and back ached constantly. She lost weight despite eating as much as she could afford. Several women from town climbed the ridge during those first weeks, ostensibly to check on her welfare, but primarily driven by curiosity. They found Eleanor working in clothes stained with dirt and sweat, her face sunburned, her hands wrapped in cloth to protect the worst blisters. They urged her to stop, to accept help, to reconsider her plan. Eleanor thanked them for their concern and continued digging. Once the trench was complete, Eleanor began filling it with rocks. She gathered stones from the ridge itself, selecting pieces that were roughly uniform in size, between 8 and 12 inches in their longest dimension. She rejected stones that were too round, preferring angular pieces that would lock together better. She laid the stones carefully, fitting them together like puzzle pieces, filling gaps with smaller rocks and gravel. She worked section by section, building up a foundation wall that rose 6 inches above ground level. The foundation was not mortared. Thomas's notes explained that dry-laid stone foundations performed better in freeze-thaw cycles than mortared ones because they could shift slightly without cracking. The key was careful fitting and adequate depth below the frost line. By mid-July, Eleanor had completed her foundation. To anyone who understood construction, the work was immediately impressive. The foundation was level within a 1/4 inch across its entire perimeter, something Eleanor had checked repeatedly using a string level and a board with a plumb line. The stonework was tight, with minimal gaps and no wobbling sections. Most importantly, the foundation sat on undisturbed subsoil below the frost line, meaning it would not heave or shift during winter freezing. Dutch Henry climbed the ridge again during the final days of foundation work and examined what Eleanor had built. He said nothing to her, but reported in town that the widow's foundation was better than most he had seen. People dismissed this as Henry being charitable to a woman who would fail anyway. Eleanor used the last few days of July to prepare her logs. She had ordered them bark-free, but they still required work. Each log needed to be inspected for defects, rotated to determine its best orientation, and measured. Eleanor marked each log with chalk, numbering them in the sequence she planned to use them. She separated them into groups based on minor variations in diameter. The most uniform logs would be used for the main walls. Logs with slight taper would be used strategically where the taper could be accommodated. Any log with significant checks, cracks that ran along the grain, was set aside for use in less critical locations. The ridge location that everyone considered suicidal was actually the result of careful calculation. Thomas had written extensively about building placement in his journals. analyzing factors that most frontier builders ignored entirely. Elevation, exposure, drainage, visibility, and access to resources all mattered, but they mattered in ways that were not immediately obvious. A cabin in the valley near water seemed convenient, but valley locations collected cold air at night, concentrated moisture, and provided poor visibility of approaching threats, whether human or animal. A cabin on a ridge seemed exposed, but exposure was not the same as vulnerability. Eleanor had studied topographical maps of the Silver Point area before leaving Leadville. She had interviewed miners who knew the region, asking specific questions about wind patterns, snow accumulation, and storm behavior. She had learned that the prevailing winds came from the west and northwest, carrying the heaviest snow loads. Valleys and draws funneled wind and created massive drifts that could bury structures completely. But ridges, particularly ridges with certain slope characteristics, created their own wind patterns. Fast-moving air over a ridge crest created low pressure that actually pulled snow away from properly positioned structures. This was not speculation. It was documented fluid dynamics that Thomas had studied in the context of mine ventilation. Eleanor had chosen her specific building site on the ridge based on Thomas's principles. The location was 30 feet below the actual crest on the eastern slope where the ground fell away at approximately 15 degrees. This position placed the cabin in a zone where prevailing winds would accelerate over the crest and pass above the structure without creating the massive pressure differentials that destroyed exposed buildings. Additionally, the eastern slope meant the cabin would receive morning sun first, helping with warmth and snowmelt, while being shielded from the direct force of western storm winds by the ridge mass itself. The drainage was critical. Water was every building's enemy, and ridge locations naturally drained better than valley positions. Eleanor's foundation work incorporated drainage principles that Thomas had used in mine construction. The trench she had excavated was lined with gravel at the bottom, creating a drainage channel that would carry water away from the foundation rather than allowing it to pool and freeze. The foundation stones were laid with slight outward cant, meaning their tops tilted away from the interior, encouraging water to run off rather than seeping inward. The 6-inch height above ground level meant the bottom logs of her walls would not sit directly on soil where moisture could wick upward through capillary action. The visibility from the ridge was another advantage Eleanor had calculated deliberately. From her building site, she could see the entire valley where Silver Point sat, the main trail approaching from the east, and the mountain slopes to the north and west. This was not about scenic views. It was about security and information. She could see weather approaching. She could see if anyone was coming up the trail. In winter, she could monitor conditions in town without having to descend in dangerous weather. She would know what she was facing before it arrived, giving her time to prepare rather than being surprised. The soil depth on the ridge, which seemed like a disadvantage, was actually beneficial for Eleanor's purposes. Thin soil meant bedrock was close to the surface, providing a solid base that would not compress or shift under the weight of her cabin. Valley soil was deeper but often softer, consisting of accumulated sediment that could settle unevenly, causing structural problems. Eleanor's foundation sat essentially on rock, providing stability that most valley cabins could not match. Every element that made the ridge seem unsuitable to conventional thinking actually made it superior for someone who understood the underlying principles. Eleanor began raising walls on August 2, 1881. The temperature on the ridge was pleasant during daylight hours, typically in the low 70s, but nights dropped into the 40s. She worked from first light until she could no longer see clearly, usually 14-hour days. The first logs were the heaviest she would handle, the base course that would sit directly on the foundation stones. These needed to be perfectly level and perfectly positioned because every subsequent log would reference them. Eleanor spent an entire day positioning just the 4 base logs, checking and rechecking with her string level. shimming with thin stone pieces where necessary, ensuring that the foundation of her walls was precisely square. The corner construction method Eleanor used was something Thomas had adapted from timber framing techniques he had seen in Pennsylvania and modified based on his mining experience with load-bearing supports. Traditional frontier cabins used notched corners, either saddle notches or dovetail notches, where logs were cut to interlock at their ends. This was fast and worked adequately, but Thomas had identified the fundamental weakness. Notches concentrated stress at specific points and created gaps that opened up as logs settled and dried. His alternative was more labor-intensive but structurally superior. Eleanor extended each wall log 2 feet past the corner intersection point. This created what looked like excessively long log ends sticking out at each corner, a visual oddness that would later contribute to people's mockery of her design. But the extensions served critical structural purposes. First, they eliminated the notch, meaning each log was solid and uncut throughout its length except where Eleanor drilled holes for the pinning system. Second, the overlapping extensions at corners created a 3-dimensional lattice where each log passed through the intersection zone and was pinned to multiple other logs from perpendicular walls. The pinning system required precision work. Eleanor used her auger bits to drill holes through the overlapping log extensions, drilling through 2 or 3 logs simultaneously depending on position in the wall. The holes were 1 inch in diameter, sized to accept the iron pins Eleanor had brought from Leadville. These pins were not standard hardware. Thomas had designed them specifically, and Eleanor had paid a blacksmith in Leadville to forge them to specification. Each pin was 14 inches long, tapered slightly at one end for easier insertion, with a flattened head at the other end to prevent it from pulling through. Eleanor inserted pins at strategic locations, driving them through the drilled holes with a heavy mallet. Some pins went vertically, connecting 3 or 4 logs in a single wall. Others went horizontally through the corner extensions, connecting logs from perpendicular walls. The pattern was carefully planned. Thomas's journal contained detailed drawings showing pin placement for maximum structural integrity. The result was a corner that could not be disassembled by pulling or prying. The only way to separate the logs would be to physically break them or drill out the iron pins, neither of which was feasible for any animal or weather condition. On August 8th, a small group of townspeople climbed the ridge to observe Eleanor's progress. She had completed 4 courses of logs, roughly 4 feet of wall height. The visitors examined the strange corner construction with its protruding log ends and visible iron pins. One man, a miner who understood structural engineering from his work underground, asked Eleanor detailed questions about load distribution and stress points. Eleanor answered clearly, explaining Thomas's reasoning. The miner nodded slowly and admitted the design was sound, perhaps even superior to standard methods. But the others in the group remained skeptical. The protruding corners looked wrong. The amount of labor required seemed excessive. One woman suggested kindly that Eleanor was overcomplicating a simple task, that many fine cabins had been built in Silver Point using traditional methods. The chinking mixture Eleanor prepared was unlike anything used in Silver Point. Standard frontier chinking consisted of mud, sometimes mixed with moss or grass, stuffed into the gaps between logs and left to dry. It worked marginally well, requiring annual maintenance as it cracked and fell out during freeze-thaw cycles. Some builders used oakum, a rope-like fiber coated in tar, which worked better but was expensive. Thomas had developed an alternative mixture during his mining work, using it to seal ventilation shafts and prevent water infiltration in underground structures. Eleanor adapted his formula for cabin construction. She started with refined clay, not the rough clay dug directly from creek banks. Refined clay had been processed to remove rocks, roots, and organic matter, creating a consistent material that would dry uniformly. Eleanor mixed the clay with water until it reached a thick, workable consistency, then added horsehair. The horsehair served as reinforcement, similar to how steel rebar reinforces concrete. Individual hairs distributed throughout the clay prevented crack propagation. When the mixture dried and contracted slightly, the horsehair held it together rather than allowing it to fracture into separate pieces. The pine resin was the critical third ingredient. Eleanor heated the resin in a pot over her fire until it liquefied, then carefully poured it into the clay horsehair mixture while stirring constantly. The resin served multiple purposes. It made the mixture waterproof, preventing moisture infiltration that would cause freeze-thaw damage. It gave the mixture adhesive properties, causing it to bond chemically to the wood rather than simply sitting in the gaps mechanically. It provided flexibility, allowing the chinking to accommodate minor structural movement without cracking. The ratio was critical. Too much resin made the mixture too sticky to work with. Too little failed to provide adequate waterproofing. Thomas had tested various ratios and documented his findings. Eleanor used his optimal formula: 10 parts clay, 1 part horsehair by volume, and 1/2 part liquefied resin. Preparing the mixture was time-consuming and physically demanding. Eleanor could only make small batches because the resin began to set within an hour of mixing. She worked in the morning, preparing a batch, then spent the afternoon applying it between logs before it hardened. Application required specific technique. She first cleaned the gap between logs, removing any dirt or loose bark. Then she packed the chinking mixture in firmly using a specialized tool Thomas had designed, a flat wooden spatula with angled edges that compressed the mixture into the gap while creating a smooth exterior surface. She worked each gap completely before moving to the next, ensuring consistent compression and no air pockets. By mid-August, Eleanor had completed 8 courses of logs, bringing her walls to approximately 8 feet in height. The chinking between every log was perfect, creating a seal that looked almost like a solid single piece running the entire perimeter of the cabin. Several builders from town made the climb to examine her work during this period. They tested the chinking by poking it with knives, trying to chip it away, and examining its adhesion to the logs. They found it harder and more durable than anything they had used. One carpenter admitted publicly that the widow's chinking technique was superior to standard methods, though he also noted that the time and effort required made it impractical for most construction projects. The women who visited during this period were primarily concerned with Eleanor's health and appearance. She had lost considerable weight. Her hands were permanently stained with clay and resin. Her face was deeply tanned from constant sun exposure. She looked exhausted, sleeping only 6 hours each night because there was too much work to complete before winter. The women urged her to slow down, to accept help, to take rest days. Eleanor thanked them but declined. She was on schedule according to her timeline. Thomas's calculations indicated she needed walls completed by early September to allow time for roof work before weather became unpredictable. She would not slow down. The door construction began in late August while Eleanor continued wall work. She could not wait until walls were complete because the door needed to be built in stages, allowing wood glue to cure between steps. Eleanor had selected 5 planks from her lumber specifically for door construction, each plank 3 inches thick, 12 inches wide, and 7 feet long. These were premium cuts, dense, straight-grained pine with no knots or defects. She had paid extra for these planks when ordering materials, specifying that they needed to be cut from heartwood, the dense inner portion of mature trees. Eleanor shaped each plank using her draw knife and planes, creating a tongue along one edge and a groove along the other. The tongue and groove joint was something Thomas had learned from observing warehouse construction in Pittsburgh. When assembled, the planks interlocked, creating a door that functioned as a single structural unit rather than separate pieces held together by cross-bracing. Eleanor worked each joint carefully, testing fit repeatedly until the tongue slid smoothly into the groove with no gaps but no binding. The process took 3 full days for 5 planks. Once fitted together, Eleanor applied hide, glue to the joints, and clamped the door assembly flat using improvised clamps made from logs and wedges. She left it clamped for 2 days while the glue cured. The resulting door was rigid and heavy, weighing approximately 90 pounds. Eleanor could barely lift one end by herself, but the weight was intentional. A heavy door resisted wind pressure and provided thermal mass that stabilized interior temperature. More importantly, a heavy door was a strong door, capable of withstanding impacts that would destroy lighter construction. The reinforcement system transformed the door from strong to virtually indestructible. Eleanor mounted 6 iron brackets across the interior face in a diagonal X pattern, using her square-cut nails driven through the brackets through the door planks and clinched over on the exterior side. Clinching meant bending the protruding nail ends flat against the wood, creating a mechanical connection that could not be pulled apart. Each bracket was secured with 20 nails, 120 total connection points. To remove a bracket would require cutting every nail individually, an impossible task for any animal and impractical for any human without specialized tools and considerable time. The hinges were mounted using a mortising technique that Thomas had adapted from mine door construction. Eleanor cut rectangular pockets into both the door edge and the door frame log, creating recesses where the hinges sat flush with the wood surface. The hinges themselves were massive, forged iron pieces weighing 15 pounds each. She secured them with iron bolts that passed completely through both door and frame log, bolted from the interior side with washers and nuts that she tightened with a wrench Thomas had left her. The hinges could not be torn free because they were integrated into the structure. Removing them would require destroying the logs themselves. The locking mechanism incorporated 2 independent systems. The primary lock was a wooden beam 8 inches wide, 4 inches thick, and 30 inches long that slid horizontally through iron brackets mounted to the door. When fully engaged, the beam extended into a mortise Eleanor had cut into the wall log adjacent to the door frame. This connected the door directly to the wall structure, distributing force across multiple logs rather than concentrating it at the hinges. The secondary lock was a vertical drop bar that fell into brackets on either side of the door, a backup system in case the primary beam lock failed. Eleanor added one final innovation, a small slot cut through the door near the lock mechanism, covered by a hinged metal plate on the exterior. From inside, she could operate both locks freely. From outside, she could reach through the slot and operate the locks only if she knew exactly where the mechanism was located and how it functioned. To anyone else, the door appeared to have no exterior access point. This was critical for security, but also for practical purposes. If Eleanor was caught outside in dangerous weather, she could unlock her own door without exposing the interior to extended cold while fumbling with external latches. The window placement was strategic rather than aesthetic. Eleanor positioned a single window on the eastern wall, 6 feet above the interior floor line, measuring 10 inches wide by 12 inches tall. The small size minimized heat loss while providing adequate light and ventilation. The high placement served multiple purposes. It kept the window above furniture height, preserving wall space for interior storage. It made the window difficult to reach from outside, reducing security concerns. Most importantly, it positioned the window where morning sun would strike directly, providing maximum light benefit during breakfast hours while avoiding afternoon glare. Eleanor cut the window opening through a single log rather than at a joint between logs, eliminating a potential structural weak point. She made the cut carefully using a saw and chisel, working from both interior and exterior to ensure clean edges. The opening was framed with additional wood pieces mortised into the surrounding log, creating a reinforced perimeter that could support the shutter system without weakening the wall. The shutter was built using the same tongue and groove technique as the door, creating a solid wooden panel 3 inches thick. Eleanor reinforced it with iron brackets in an X pattern matching the door construction method. The shutter was hinged on the interior and could be secured with a wooden bar that dropped into brackets. But the shutter alone was not sufficient for Eleanor's requirements. She needed a system that provided light while maintaining security and insulation. Eleanor stretched her heavy canvas across the window opening on the interior side, tacking it firmly to the wall log above and below the window. The canvas was 12-ounce weight, thick enough to be opaque, but thin enough to be somewhat translucent. Once secured, she applied her clay horsehair resin mixture directly to the canvas, building up layers over several days. Each layer was thin, approximately 1/8 inch, and allowed to dry completely before the next application. After 6 layers, the canvas was embedded in a 1/2-inch thick composite material that was rigid, waterproof, and remarkably strong. The canvas composite window covering allowed diffused light to enter even when the wooden shutter was open, providing gentle illumination during daytime hours. It was completely waterproof, preventing any moisture infiltration around the window. It provided insulation, reducing heat loss through what was traditionally a cabin's weakest thermal point. Most importantly, it was far stronger than the rawhide or oiled paper most frontier cabins used for window coverings. Eleanor tested it by striking it with a hammer. The composite flexed slightly but did not tear or crack. A bear could claw at it, but penetration would require sustained effort, time Eleanor would have to respond to the threat. By September 1st, Eleanor's walls were complete at 10 courses high, approximately 10 feet at the peak where the roof would sit. She had left the front and back walls slightly higher than the sides, creating a gentle slope for water runoff. The door was installed and tested, swinging smoothly on its massive hinges and locking securely with both beam and drop bar systems. The window was complete with both shutter and canvas covering functional. She was ready to begin roof construction, the most critical phase of the entire project. Thomas's journals contained more notes on roof engineering than any other single topic because he understood that roofs were where most frontier structures failed. The roof construction followed principles Thomas had developed after analyzing multiple mine tunnel collapses and building failures. The fundamental problem with most frontier roofs was inadequate support structure combined with poor weatherproofing. Simple pole rafters sagged under snow load, creating pockets where more snow accumulated, accelerating failure. Bark and sod coverings leaked during rain and provided minimal insulation. Thomas had designed a multi-layer system that distributed weight across redundant supports and created a genuinely waterproof seal. Eleanor began with ridge poles, carefully selected logs 8 inches in diameter that spanned the 20-foot width of her cabin. She positioned these poles perpendicular to the long axis of the structure, spacing them exactly 18 inches apart, center to center. This close spacing was unusual. Most builders used 24 or 36-inch spacing to reduce material costs. But closer spacing meant each individual pole carried less weight and deflected less under load. Eleanor notched shallow seats for each ridge pole into the top wall logs, creating positive location that prevented lateral movement. She secured each pole with iron spikes driven at angles, pinning them to the wall structure. Across the ridge poles, Eleanor laid split planks she had prepared during evening hours over the previous weeks. These planks were hewn from logs using an axe and then smoothed with her draw knife, creating boards roughly 2 inches thick and 8 inches wide. She laid them like shingles, each plank overlapping the one below by 4 inches. The overlapping pattern meant water hitting any point on the roof would run down across multiple plank layers before potentially finding a gap. Eleanor pegged each plank to the ridge poles using wooden pegs she had whittled by hand, driving 2 pegs per plank per pole, creating hundreds of individual connection points. Over the planks, Eleanor laid birch bark she had harvested from trees on the lower slopes. Birch bark was naturally waterproof, flexible, and durable. She laid it in overlapping sheets, each piece covering gaps in the layer beneath, creating a continuous barrier across the entire roof surface. The bark alone would have been adequate for basic waterproofing, but Eleanor did not trust single-layer systems. Over the bark, she spread her clay mixture, working it into a continuous layer approximately 1 inch thick. The clay sealed every potential gap and added substantial weight that helped secure the bark against wind uplift. The final roof layer was living sod, grass and soil cut in rectangular sections from the ridge and laid like tiles over the clay. The sod would root and create a living roof that provided insulation, absorbed rainwater, and created habitat for small plants that would further stabilize the surface. The total roof weight was substantial, easily several tons, but Eleanor's wall construction and close-spaced ridge poles supported the load without difficulty. The multiple layers made the roof functionally waterproof, well-insulated, and strong enough that even if a bear climbed on top, it could not break. Through to the interior, Eleanor completed the roof structure by September 18th, working through several days of light rain that tested her partially completed work. The overlapping planks and birch bark shed water effectively even before the clay and sod layers were added. By the time she laid the final sod sections, she had a roof that was superior to anything in Silver Point. It would not leak, it would not collapse under snow, and it would last for decades with minimal maintenance. The interior work began immediately after roof completion. Eleanor built a stone fireplace in the northwest corner, gathering flat stones from the ridge and stacking them with mud mortar. The fireplace design came directly from Thomas's journals. He had studied heating efficiency and smoke management, understanding that most frontier fireplaces wasted heat and filled cabins with smoke because of poor design. Eleanor's fireplace included a smoke shelf, a horizontal ledge partway up the chimney that prevented downdrafts and reflected heat back into the room. The chimney was narrow at the top, too narrow for animals to enter, but adequate for smoke exhaust. Eleanor built a sleeping platform along the eastern wall, raising it 2 feet off the ground. The elevation kept her away from cold air that settled at floor level and provided storage space beneath for supplies and tools. She constructed a small table using carefully fitted joinery, no nails, just precisely cut wood pieces that locked together. She built shelves high on the walls, braced with iron brackets, creating storage for food, clothing, and Thomas's journals. Every element was overbuilt by frontier standards, but perfectly suited to Eleanor's requirements for durability and functionality. By September 30th, Eleanor had moved all her possessions into the completed cabin. The structure had taken exactly 4 months to build, working alone, investing approximately 700 hours of labor. The total material cost was $183 plus hauling fees, tools, and incidentals, bringing the total investment to approximately $250. A standard frontier cabin built by 2 men in 1 week would cost perhaps $40 to $60 in materials and labor. Eleanor's cabin cost 4 times as much and required 30 times the labor. But what she had built was not comparable to a standard cabin in any meaningful sense. The first serious test came on October 7th. A storm system moved in from the northwest, bringing high winds and heavy rain. Weather in early October was typically mild, but this system was unseasonably strong, pushing into the mountains ahead of a cold front. Winds reached sustained speeds of 40 miles per hour, with gusts above 60. Rain fell in sheets, driven horizontal by the wind. The storm lasted 14 hours, from afternoon through the night into the following morning. Eleanor sat inside her cabin during the storm, warm and dry, listening to the wind howl across the ridge. She had a fire burning in her stone fireplace, which drew perfectly with no smoke backing up into the room despite the strong winds outside. She could hear rain hammering the roof but saw no leaks, no drips, no moisture infiltration anywhere. The walls did not shake or creak. The door remained sealed, no drafts penetrating around its edges. The window shutter held firm with no rattling. The cabin felt solid, immovable, as though it had been carved from a single piece of stone rather than assembled from individual logs. In Silver Point below, the storm caused significant damage. 3 cabins lost portions of their roofs when wind caught under bark shingles and peeled them away. One building, a storage shed near the trading post, collapsed completely when its corner joints failed and the structure folded in on itself. Multiple buildings reported leaks, some severe enough to soak bedding and ruin stored goods. 2 families spent the night huddled in the trading post after their own cabins became uninhabitable due to wind-driven rain pouring through gaps in walls and roofs. The morning after the storm, Eleanor descended to town for supplies. People asked immediately about her cabin, expecting to hear that it had suffered damage. Eleanor reported that she had experienced no problems, no leaks, no drafts, no structural movement. Several people expressed skepticism, assuming she was minimizing damage out of pride. Dutch Henry and 2 other men climbed the ridge that afternoon to inspect her cabin personally. They examined the roof, the walls, the corners, the door, and the window. They found no damage, no loose elements, no signs of stress. Dutch Henry told Eleanor directly that her cabin was built better than any structure he had seen in 20 years of frontier construction. Word of Eleanor's cabin surviving the October storm spread through Silver Point, but skepticism remained widespread. One good storm was luck, people said. The real test would come in winter when temperatures dropped below zero, and snow accumulated for months. A few builders asked Eleanor specific questions about her construction techniques, genuinely curious about the methods that had proven so effective. Eleanor answered every question completely, explaining Thomas's reasoning and offering to show anyone who climbed the ridge exactly how she had built each element. She had no interest in keeping secrets. If her techniques could help others build better structures that honored Thomas's memory more than any private achievement. On November 9th, a second storm struck, this one bringing the first significant snow of the season. 8 inches fell overnight, accompanied by winds strong enough to create drifts 3 and 4 feet deep in protected areas. The temperature dropped to 18 degrees, cold enough that poorly insulated structures became uncomfortable or even dangerous. 3 cabins in Silver Point suffered damage during this storm. One lost its door when wind pressure combined with ice accumulation in the frame created enough force to tear the hinges free. The family inside spent 4 hours in near-freezing conditions before neighbors helped them secure a blanket over the opening and move their children to another cabin for the night. Another cabin experienced a partial roof collapse when snow accumulated unevenly, creating a load concentration that exceeded the strength of the ridge poles. The collapse happened at 3 in the morning, waking the family with a crash as one section of roof sagged inward, dumping snow and broken planks into the interior. No one was injured, but the cabin was uninhabitable until repairs could be made. The third damaged structure was a prospector's shack on the edge of town, built hastily the previous summer with minimal attention to quality. The entire structure shifted off its foundation during the storm, creating gaps between logs large enough to see through. The prospector abandoned it and moved into the boarding house. Eleanor's cabin handled the storm without incident. The multi-layer roof shed snow effectively as wind kept the surface relatively clear. The small amount of snow that accumulated was well within the structural capacity of her roof system. Inside, the temperature remained comfortable with just a small fire in her stone fireplace. The thick walls, tight chinking, and sod roof provided insulation that standard cabins could not match. Eleanor used less firewood than most families in town while maintaining better interior warmth. 2 weeks after the November storm, a delegation of townspeople climbed the ridge to speak with Eleanor. The group included Dutch Henry, Michael Brennan from the trading post, the town's doctor, and 3 family men who had suffered damage during recent storms. They found Eleanor processing firewood, cutting logs into stove-length pieces using a bucksaw. They asked if she would be willing to explain her construction methods in detail and perhaps help others implement some of her techniques when spring building season arrived. Eleanor agreed immediately. Over the course of that afternoon and into the evening, she walked the group through every aspect of her cabin's construction. She showed them the foundation work, explaining how depth and drainage prevented frost heave. She demonstrated the corner pinning system, letting them examine how the iron pins connected multiple logs in three-dimensional patterns that distributed stress. She explained her chinking mixture, providing the exact ratios Thomas had developed and describing why each ingredient mattered. She opened her door to show the reinforcement brackets and explained the mortised hinge system. She detailed the multi-layer roof construction and the principles of weight distribution across closely spaced ridge poles. Dutch Henry took notes, sketching details in a small notebook. He asked technical questions about load calculations, thermal properties, and material selection. Eleanor answered each question, often referring to Thomas's journals, which she brought out and showed to the group. The visitors were impressed not just by the construction quality, but by the depth of engineering knowledge that informed every decision. This was not intuitive building or traditional craftsmanship. This was applied engineering, adapted from mining and industrial construction and modified for frontier conditions. As November turned to December, the weather remained unusually mild for several days, temperatures climbing into the 40s during afternoon hours. Old-timers in Silver Point recognized the pattern. Warm spells in late autumn often preceded major winter storms, as though the mountains were drawing breath before unleashing their full force. On December 15th, the barometric pressure began dropping steadily. The sky took on a peculiar yellowish cast that experienced mountain residents knew meant heavy snow was coming. By December 17th, everyone in Silver Point was preparing for a significant storm. The preparations varied based on resources and experience. Wealthy families stocked extra firewood, food, and water, securing their cabins and making sure livestock had adequate shelter. Poorer families did what they could, often doubling up with neighbors in the sturdiest available buildings. The town's leaders organized a shelter in the church, a relatively new structure built with better-than-average construction, where people without adequate housing could wait out the storm. Businesses closed early, and miners coming off shift were advised to stay in town rather than attempting to reach outlying cabins. Eleanor made her own preparations on the ridge. She had been stockpiling firewood since October, and by mid-December she had enough split and stacked wood inside her cabin to last 2 weeks without needing to go outside. She had filled every container with water, anticipating that snow might make the trail down to the creek impassable. Her food supplies were adequate for extended isolation, primarily dried goods, flour, beans, and salted meat. She had candles, lamp oil, and Thomas's journals to read if the storm lasted multiple days. She was as prepared as anyone could be. The storm arrived on the evening of December 18th. It began with light snow, delicate flakes falling vertically in still air. Within an hour, the wind picked up, shifting to come directly from the northwest. By midnight, conditions had deteriorated into a full blizzard. Snow fell so heavily that visibility dropped to less than 10 feet. Wind gusts exceeded 70 miles per hour, creating a roar that sounded like continuous thunder. The temperature plummeted to 5 degrees below zero, with wind chill driving effective temperature far lower. In Silver Point, the storm's impact was immediate and severe. Several cabins began experiencing problems within the first hours. Wind found gaps in chinking and exploited them, tearing away mud and moss that had seemed adequate in calmer conditions. Snow driven horizontally penetrated around doors and windows, accumulating inside structures faster than residents could shovel it back out. One family's door blew open when the wooden bar securing it cracked under pressure. They managed to close and resecure it using rope and furniture, but not before several inches of snow had entered their cabin, along with dangerously cold air. The church shelter quickly became overcrowded as families whose cabins were failing sought refuge. By morning of December 19th, nearly 60 people were crammed into a space designed for 40. They huddled together for warmth, sharing blankets and body heat. The church's fireplace could not generate enough warmth for so many people in such cold conditions. Several children developed symptoms of hypothermia and were placed closest to the fire. The adults endured, waiting for the storm to pass, but conditions were miserable and dangerous. On the ridge, Eleanor maintained her routine as much as possible. She kept her fire burning steadily, feeding it split wood every few hours. The stone fireplace radiated heat efficiently, and the cabin's insulation retained warmth so effectively that interior temperature remained around 60 degrees. Even as exterior conditions reached historic extremes. She could hear the wind howling outside, a constant presence that ranged from low moaning to shrieking crescendos during the strongest gusts. But inside, she was safe. The blizzard continued without pause through December 19th, through the night into December 20th, and showed no signs of weakening on the 21st. 3 full days of unrelenting wind and snow created conditions that even the oldest residents of Silver Point had rarely witnessed. Snow accumulation in the valley reached depths of 6 to 8 feet in areas where drifting was minimal, in places where wind funneled between buildings, or along draws, drifts built to 15 and 20 feet, completely burying smaller structures and blocking doors even on larger buildings. In town, the situation deteriorated steadily. The church shelter ran low on firewood on the second day. Men attempted to venture out to nearby woodpiles, but found the blinding snow and brutal cold made even short distances dangerous. One man became disoriented 15 feet from the church door and wandered in the wrong direction. Others heard his shouts and formed a human chain, eventually pulling him back inside, but the incident demonstrated how deadly conditions had become. After that, no one left the shelter except in absolute emergency. Families trapped in their own cabins faced different challenges. Those in well-built structures endured cold and discomfort but remained relatively safe. Those in poorly constructed cabins fought a losing battle against wind and snow. The Hendricks family, living in a cabin built hastily 2 years earlier, watched as snow began sifting through gaps between logs that had seemed tight enough during normal weather. By the second day, they had several inches of snow accumulated on their floor despite constant efforts to sweep it back outside. The interior temperature dropped to barely above freezing. They burned furniture to supplement their dwindling firewood supply, breaking apart chairs and a small table to feed their inadequate fireplace. The Morrison family experienced a catastrophic failure on the night of December 20th, when a section of their roof collapsed under snow load. The collapse occurred over the sleeping area where their 3 children were bedded down. The parents heard creaking moments before the failure and managed to pull the children clear seconds before roof poles and planking crashed down, bringing a massive load of snow with it. The family spent the rest of the night and the following day huddled in the remaining intact portion of their cabin, using blankets and their own bodies to shield the children from cold air pouring through the roof opening. They survived. But 2 of the children developed severe frostbite on their feet and hands. The prospector named Carlson, who lived alone in a small cabin on the eastern edge of town, was not as fortunate. His cabin was old, built 8 years earlier by someone else, and poorly maintained. When the storm hit, Carlson was already sick with what might have been influenza or pneumonia. He was too weak to maintain an adequate fire. His cabin leaked cold air through dozens of gaps. On the 3rd day of the storm, his chimney became blocked by snow and ice, filling his cabin with smoke when he tried to restart his fire. Neighbors found him 2 days after the storm ended, dead from some combination of cold exposure, smoke inhalation, and his pre-existing illness. He was 52 years old. Throughout the 3-day ordeal, people in town had no information about Eleanor Hartwell on the ridge. The general assumption was that she was either dead or in desperate condition. The ridge was more exposed than the valley. Wind speeds there would be even higher. Snow accumulation might be less due to wind scouring, but the cold would be more extreme. Several people expressed regret that they had not insisted more forcefully that Eleanor abandon her ridge location. Some prayed for her survival. Others, more pragmatic or perhaps more pessimistic, began discussing who would climb up to check on her body once the storm cleared, and whether her cabin, if it still stood, could be salvaged for materials. Eleanor herself was unaware of the drama and suffering occurring 300 feet below her position. She could see nothing through the blizzard. The whiteness outside her window was absolute, even during what should have been daylight hours. She maintained her routine, rising at her normal time, eating simple meals, tending her fire, reading Thomas's journals, and sleeping peacefully at night. The wind noise was remarkable, sometimes violent enough that she wondered if it might somehow tear the roof away despite its strength. But the structure never moved, never creaked or groaned. It simply stood, solid and immovable. Inside the cabin, Eleanor's environment remained remarkably stable throughout the storm. The temperature stayed between 58 and 64 degrees, warm enough for comfort with just one layer of wool clothing. She adjusted her fire size to maintain this temperature, burning less wood than she had anticipated would be necessary. The stone fireplace design Thomas had specified proved its worth. The smoke shelf prevented downdrafts even during the most violent wind gusts. The heat radiated from the stone mass long after she banked the fire for sleep, creating gentle, consistent warmth rather than the boom-and-bust temperature swings typical of simpler fireplaces. The walls showed no signs of stress or infiltration. Eleanor inspected them multiple times during the 3 days, using a candle to examine the chinking between logs in fine detail. She found no cracks, no gaps, no places where wind was penetrating. The clay horsehair resin mixture remained perfectly sealed, flexible enough to accommodate any minor structural movement, but rigid enough to maintain its integrity. Snow that accumulated against the exterior walls created an additional insulation layer, actually improving the cabin's thermal performance during the worst of the cold. The roof performed exactly as Thomas's calculations had predicted. Eleanor could hear snow accumulating above her, a soft crushing sound as weight built up, but she felt no concern. She knew the close-spaced ridge poles could support far more weight than any storm would deliver. The multi-layer construction meant that even if one layer failed, which seemed impossible, multiple backup layers would maintain integrity. During the day, she could see dim light filtering through her canvas window covering, confirming that snow was not completely burying the cabin. The steep roof pitch and wind scouring kept accumulation manageable. Eleanor spent her time productively. She read through Thomas's journals again, paying particular attention to sections where he had documented his thought processes and design decisions. She understood now, living inside the result of his knowledge, exactly why each element mattered. The foundation prevented frost heave that would have cracked walls. The corner pins distributed load in ways that simple notches could not. The chinking sealed against wind that would have made a standard cabin uninhabitable. The roof layers shed water and supported snow that would have collapsed simpler construction. Every detail worked together, creating a system that was far greater than the sum of its parts. She also thought about the town below, wondering how people were managing. She hoped they were safe, but recognized that many probably were not. Frontier cabins were not designed for storms of this magnitude. She felt no satisfaction in this knowledge, only a quiet sadness that Thomas's insights had not been available to more people sooner. If others had built using his methods, fewer would be suffering now. After the storm, she would share everything she knew, helping anyone who wanted to build properly. That seemed like the right way to honor Thomas's memory. On the evening of December 21st, Eleanor noticed the wind beginning to diminish. The constant roar that had been her companion for 3 days gradually decreased to occasional gusts separated by periods of relative calm. The snow continued falling, but less heavily. By midnight, both wind and snow had stopped completely. The silence was profound, almost startling after so much noise. Eleanor banked her fire and slept deeply, knowing the worst had passed. She woke on December 22nd to brilliant sunshine streaming through her window. The quality of light told her that snow covered everything outside. She opened her door carefully, pushing against resistance, and found snow had drifted against the entry to a depth of 3 feet. She cleared it methodically, shoveling a path away from the door. When she finally stepped outside, the vista was breathtaking. The entire landscape was transformed, covered in smooth white that sparkled in morning sun. The air was brutally cold, but perfectly still. Eleanor stood on the ridge in the crystalline morning air and looked down at Silver Point. From her elevated position, she could see the entire town laid out below, and what she saw troubled her deeply. Many buildings were partially buried under massive drifts. Several structures had visible damage, roofs sagging or collapsed, walls pushed inward. Smoke rose from only about half the chimneys that should have been active, suggesting many families had abandoned their cabins or were unable to maintain fires. The main street was completely obscured under snow, indistinguishable from the surrounding terrain except for the pattern of buildings on either side. Eleanor gathered supplies and began the descent. The trail was buried under 4 feet of snow in most places, deeper where drifting had occurred. She broke trail slowly, using a long stick to probe ahead for the path, post-holing through snow that sometimes reached her waist. The journey that normally took 20 minutes required 2 hours. She arrived in town exhausted but driven by concern for what she might find. The scene in Silver Point confirmed her fears. People were emerging from buildings looking haggard and shaken. Several families were working to dig out doors that had been completely blocked. Others were assessing damage to roofs and walls. Eleanor heard about the Morrison family's roof collapse and went immediately to check on them. She found them in the church shelter, the children wrapped in blankets near the fire. The 2 with frostbite had blackened fingers and toes that the doctor was treating with limited supplies. Eleanor spoke quietly with the mother, offering what comfort she could, knowing that those children might lose digits to amputation. She learned about Carlson's death from Dutch Henry, who had been part of the group that found the body. Henry looked exhausted and older than he had just days earlier. He told Eleanor that at least 6 families had experienced severe damage to their cabins, 3 of which were now uninhabitable. The church was still sheltering nearly 40 people who had nowhere else to go. Food supplies were adequate but not abundant. Firewood was becoming a concern because so much had been buried under snow. By midday, word had spread through town that Eleanor Hartwell had descended from the ridge. People began gathering, asking questions. How had she survived? Was her cabin intact? Had she suffered damage? Eleanor answered simply that her cabin had performed well, that she had remained warm and dry throughout the storm, and that she had experienced no damage. Several people expressed disbelief until Dutch Henry, Michael Brennan, and 2 others who had visited her cabin in November confirmed her account. They explained to doubters that Eleanor's construction methods were fundamentally different from standard building, that her cabin had been engineered specifically to withstand extreme conditions. The doctor, a practical man named Harrison, who had seen too much suffering over the past 3 days, asked Eleanor directly if she would be willing to help people rebuild using her techniques. He explained that spring would bring new construction as families repaired damage or built replacement structures. If Eleanor's methods could prevent future tragedies, the town needed to learn them. Eleanor agreed without hesitation. She would help anyone who asked, providing detailed instructions and even hands-on assistance if needed. She had not come to Silver Point seeking recognition or profit. She had come to build a life and to prove that Thomas's knowledge was valuable. Both goals could be served by sharing what she knew. Over the following days, as Silver Point dug out from the blizzard and began recovery efforts, Eleanor became a central figure in planning discussions. Men who had mocked her 6 months earlier now sought her advice on foundation work, corner construction, and roof design. Women who had pitied her exhausted appearance during building season now understood that her effort had been investment rather than foolishness. The town's attitude toward Eleanor shifted fundamentally. She was no longer the strange widow with impractical ideas. She was the woman whose knowledge had saved her life and might save others. Eleanor spent the winter of 1881 to 1882 in Silver Point, dividing her time between her ridge cabin and the town below. She worked with Dutch Henry and other builders to document Thomas's construction techniques in clear, practical terms that men with basic carpentry skills could understand and implement. They created written instructions for the corner pinning system, the chinking mixture, the multi-layer roof construction, and the reinforced door design. Dutch Henry sketched detailed drawings showing dimensions and assembly sequences. Michael Brennan began stocking the specialized materials Eleanor's methods required: iron pins, heavy brackets, refined clay, and canvas. When spring arrived in 1882, 9 families began new construction projects or major rebuilds using what became known locally as Hartwell methods. Eleanor visited each site multiple times, answering questions, demonstrating techniques, and helping solve problems that arose during implementation. The builders discovered that Eleanor's methods were indeed more time-consuming and expensive than traditional construction, but they also discovered that the results were dramatically superior. Cabins built using Hartwell methods were noticeably warmer, drier, and more durable than standard structures. The Morrison family, whose children had survived the roof collapse, built a new cabin using every technique Eleanor recommended. The father, a man named Robert Morrison, who worked as a miner, told Eleanor that he would never again trust his family's safety to cheap construction. He spent 4 months building their new cabin, taking time off from mine work to do the job properly. When completed, the cabin was solid enough that Morrison joked it could survive the cabin being dropped on it from above. His wife, Margaret, thanked Eleanor with tears in her eyes, explaining that she could now sleep without fear that the roof would collapse on her children. Eleanor herself continued living on the ridge, becoming a permanent and respected member of the Silver Point community. She took work as a seamstress, her original trade, sewing for families and miners who needed clothing repaired or created. The income was modest but adequate when combined with the small savings she had remaining. She lived simply, finding satisfaction in her independence and in the knowledge that she had honored Thomas's memory by proving his ideas worked. In 1886, Eleanor married again, a surprising development to many who had assumed she would remain a widow. Her new husband was a surveyor named James Crawford, who had come to Silver Point mapping railroad routes. Crawford was quiet, intellectual, and respectful of Eleanor's capabilities. He had visited her cabin professionally to document the ridge geography and had been impressed by both the structure and the woman who had built it. They married in a simple ceremony and continued living in Eleanor's cabin, which Crawford declared the finest private residence he had encountered in 15 years of frontier work. Eleanor lived until 1904, dying at age 57 from pneumonia. She and James had no children, but they had built a life together that was comfortable and meaningful. James died 2 years after Eleanor, and both were buried in the Silver Point Cemetery on a hillside with a view of the ridge where Eleanor's cabin still stood. The cabin itself remained occupied for decades after Eleanor's death, passing through various owners who maintained it carefully, recognizing its exceptional quality. It became a landmark in the region, pointed out to newcomers as an example of what could be built when intelligence and determination combined with proper engineering knowledge. By the early 1900s, construction techniques across mining communities in Colorado had evolved significantly, incorporating many principles that Eleanor had demonstrated. The specific methods varied, but the underlying concepts remained consistent. Proper foundations, careful log fitting, reinforced corners, superior chinking, and multi-layer roofs became standard practice for anyone building seriously. The phrase "built like the Hartwell cabin" became a compliment in Silver Point and surrounding towns, signifying construction that could withstand anything the mountains offered. Modern historians examining frontier architecture sometimes note Eleanor Hartwell as an example of knowledge transfer in isolated communities. Her story illustrates how innovation often comes not from invention of entirely new techniques, but from the intelligent application of existing knowledge in new contexts. Thomas had adapted mining engineering to cabin construction. Eleanor had translated his written plans into physical reality. Together, though separated by death, they had created something that outlasted both their lives and influenced how an entire region approached the fundamental human need for shelter. The cabin on the ridge stood until 1963, when it was finally dismantled after 182 years of continuous use. By then, modern construction methods had made it obsolete for practical living, though structurally it remained sound. Parts of it were preserved by local historical societies. The iron pins that had connected the corners were donated to a museum in Denver. One of the original door hinges became part of a display on frontier engineering. But the most important legacy was not physical. It was the knowledge that a widow, working alone, grieving her husband, had built something impossible by refusing to accept that traditional methods were the only methods. Eleanor Hartwell proved that with time, effort, and careful thought, one person could build something genuinely impervious to nature's fury. And in doing so, she left a legacy carved not just in logs and stone, but in the minds of everyone who learned that sometimes the impossible is simply a matter of understanding structural principles, using quality materials, and refusing to accept that difficulty means impossibility.